My name is Jack Klom. I'm from Klom & Sons in Ocala, Florida. On this tape, we will be showing how to be able to fabricate and design a staircase all the way from the different steps of creating the pattern to the shop work, also as far as with on-site work and the different types of tooling that can be made not only in your shop but also using pyramid rolls and other tools to be able to make your job much easier to be able to create and fabricate a curved stair. Ideas usually start from either through magazines or books that the clients or the architect usually have. In this particular case, through the door, the client brought this photograph, or in this case here, it was a magazine clipping. As you can see from the radius that we have in the staircase, that one side is 44 degrees, the other side is 24 degrees. So we have almost 20 degrees difference that will be in a vertical measurement here, which depends upon what sort of design that you can sit between the two parallel bars. As you can see through the drawing that we have drawn to scale, for the beginning portion of the internal radius is 44 degrees. Climbing up toward the top of that particular pitch, we will have a landing which code requires that you are not able to have any more than 12 feet in height before you have a landing, before you can continue the rest of the steps to the top of the finished staircase. Some compromises do need to be made in the design that's on the very steep sections of the rail. Unlike woodwork, as far as in the areas that you have lesser degrees, getting closer to what the landings or a rectangular rail will have much more space to be able to work with. In most cases, what I always prefer to do is to be able to go to the maximum height of the railing that the building code will require me for. This is 38 inches from the nose of the step to the top of the rail. This enables me to have maximum amount of design in between my parallel bars, especially when it is conceived of using castings and other elements that cannot be shrunk to be able to still utilize these pieces that will still work on your rectangular landing sections and on less of a pitch. The very first sections that I always like to be able to conceive first are the most difficult ones. This is the first portion of the staircase, the steep section. This means that whatever will work in the smallest area will certainly work in a much larger area just by adding perhaps another bar that will circle around the wave design in this particular case. By using just regular vertical pickets or vertical elements, you are not faced with this particular type of difficulty. So you do need to be able to understand that there are certain compromises through certain designs in wave or freeform designs that you have to be able to work within the space that you have to work with. And the compromising areas that you will find first, well, first off is in the very first section that we'll be doing, the steepest pitch, which is the smallest amount of area. When we will show you the finished product, that one of the bars that are parallel in here, which is 3/4 inch round, will have to be eliminated because otherwise there was so much congestion in a very small area that made it not as compatible to the landing area or the upstairs landing areas that surrounded this particular staircase also. We are about ready to place our 1/8 inch Lewin on top of the stringer that we have on the staircase here. I will be screwing this down with drywall screws prior to using a magic marker to mark to the underside of the Lewin which will create the template for the curvature that I need to be able to bend my flat bar for. Using a cordless drill always comes in very handy. For one, that being able to put a Phillips head screwdriver to be able to do your drilling or your screwing straight in through your drywall screw into the stringer. Now for an irregular curve on your staircase, other than a perfect radius, by putting multiple layers of luan on top of the stringer, you're able to do the complete pattern of the curve, so that in case it does a different radius halfway up the stringer, you're able to create all of your bends at the shop. Before taking the luan off of your stringer, that you would make registration marks from one piece of luan overlapping the other, so that you are able to recreate the exact curve and having your patterns aligned at the shop. Also that we have marked up underneath the piece of 1/8 inch luan, so that we have not only marks on the very top, but marks underneath for the curvature. Another identification that you want to be able to do is not only with a line marking on the luan underneath, also with X's, and also by identifying pattern 1 to pattern 2, so that there is no question as far as a perfect alignment when you do go back to the shop. Now that we have the luan securely in place, I'm about ready to go ahead and run my magic marker along up underneath the edge by putting pressure on the top of the luan to make sure that my marker does not encroach into the inside radius. I will also crawl up underneath here on the other side, and I will reach as far as I can, but I'll need to be to the other side to be able to mark the rest of the curvature. Now, after that we have marked up underneath the luan, I'm about ready to take the pattern off, and then we will go ahead and see if everything is marked correctly. As soon as you take your luan off of your stringer, it's very important to be able to mark bottom or top as the stair progresses up on the pitch. If you have other identifying marks, you need to make sure that those are on your piece also. After doing the marking with your template on your luan, it's very important on that particular section to make sure that you do take the degree measurement off of your smart level by placing it on the pitch of the stringer. It takes a minute before that it identifies itself. There is a hold button on this also. Once it stops fine-tuning itself, you're able to take the measurement and transport the measurement to your luan, so that you know on that particular template you need to be able to have this particular degree. Now that I have taken my degree measurement off of the stringer, I'm making sure that my 24.5 degree slope is identified on the piece that I will be bending at the shop. Now that we have come from the job site and we have made our template by laying the door skin or luan on the closed stringer, which you see right here as far as the magic marker that was marked up underneath the luan to follow the configuration of the curved portion of the staircase. What I have done here also is that I have a degree measurement that I have taken from my smart level. I mark this right on the template to make sure that I will not be understanding this curve from a different degree in the staircase. Now there are two different ways as far as bending your material to be able to follow the curvature of your staircase. One is a pyramid roll. The other is to be able to have a flat table with two radiused pieces that your flat bar will fit in between, which probably will cost you no more than about $40 to be able to create on top of a fixed table that you will have in your shop, instead of having to spend thousands of dollars for a pyramid roll. So you are able to do these kind of staircases without having major expense. With the pyramid roll, that I have taken my material, and what you see is I have one that's marked with 2 turns, one that's marked with a turn and a half, and 1 turn. These are pre-bent pieces that are run through the pyramid roll only one time. Anytime that you run any sort of material through a pyramid roll for the second time, that will not be a true radius of what you would like to be able to have. So you want to be able to have this one roll through the pyramid roll at the first time. So by having these pieces that I have pre-bent, I will put this on top of my template, which has the curve to be able to see, well, will I adjust the pyramid roll with 1.5 turns, or will it be better with a 1 turn radius? Now what I mean by a turn is that I'm screwing the top portion of the pyramid roll down onto the material, which has the force to be able to have more curve than the other pieces. So the more times that I turn the screw down, I will get a tighter radius. So as you can see, with 1 turn, that it fits close in between the center of my piece compared to the 1.5 turns. So the selection in the pyramid roll that I will turn it 1 turn and then perhaps about another 1/8 of a turn to be able to have a little bit more curvature in my piece than this has right here. Now what you're seeing here at the very end where this mark is, when any time that you do any rolling, that you have a dead end, a flat spot at the very end of it. This is where that you are not able to use from here out as a comparison for putting your piece on the template or on the pyramid roll. Being able to bend your material, your flat bar, your frame for your staircase, it does not take a whole lot of money to be able to be set up to be able to bend this not only in your shop but also on the job site. To be able to have a table with pieces that are backed on up so that you're actually, this is a table bending fork of what I call this here. What you're able to do is put your flat bar in here, put your back into it, and start to bend your material. Now by having aluminum, a special type, which is 6063, is much easier to be able to bend than your 6061. Going to the job site, there are 2 different tools to be able to have here without having to depend upon any sort of electricity, and you're able to do this very easy without having to depend upon someone else. One is the Strataflex. The other is this particular type of bender right here. It is a hydraulic pump with a ram. It will bend on up to 2¼ inches of not only cap rail, but yet in any sort of flat bar also from 2½ or 2¼ down. So that is another tool to be able to have at the job site. One thing that also works out very well is having a pair of good bending forks. Now I've had bending forks that I've made before that have taken an awful lot of effort to be able to hold on to them and to be able to manipulate your piece. By having these fabricated in pipe, Schedule 40 enables you to cut down on the weight. Also, with the length of the arms, that you're able to have an awful lot of mechanical ability to be able to twist your material. Because once you get done rolling the flat bar, you need to turn the flat bar into a helix. So what we will be showing here is to be able to take the two pieces of flat bar in between the two bending forks and twisting them as we go up the stair. This can be done on the job site, but also I like to be able to pre-bend the pieces at the shop so that I spend the least amount of time on the job site. It still needs to be tuned better once you put your piece onto the stringer at the job site. So what I'm about ready to show here is that I have my template. I know the curvature that I need to be able to have. Now I'm going to start bending this right on the table itself. What we have here is a piece of 1.5 inch by 1/2 inch material, 6063 aluminum. Selecting this particular type of material is very easy to be able to bend. Also, that it gives you the amount of mass of material to be able to make your piece look much more stately in an atmosphere of where the staircase needs to be with the size. What we have right here is 2 welded pieces of plate that are backed up by gussets with a table that is pinned to the ground so that when I start to bend this here, that it will not move on me. Now there's a little bit more to just bending and putting your back into it. There are certain parts of your body that you use to be able to control on how much power that you actually have. One is your forearm, well, starting off with your hands to begin with, your forearm, your lats, and also your pecs. Also, the other is on how much weight that you actually have to be able to put into the piece. For bending, I always make sure that I always have my foot in back of me instead of side by side to make sure in case there's anything that ever slips that I will not wind up with an anvil in my back or something else that I have fallen back on and has paralyzed myself. So by starting on off, the first thing that I will be doing is using my forearm with my weight to be able to hold them steady and start to bend. Okay, every time that you start to move this on in, if you are not able to watch the amount of material that you push into your jig so that it is bent exactly the same way throughout each one of your movements here, you will put little lines with a magic marker. This means that you will slide it up to that same place, and that's where that you will be using the same amount of force, providing that you are controlling the force of what your body is able to control. Now, the more that you get closer to the very end of your piece of material, the less amount of mechanical ability that you will be able to have in bending this piece. Normally, I have a much larger piece that I will bend because I do have more mechanical advantage. I'm going to slip this on in a little bit further here until where I feel as if I'm not giving the same amount of twist or pull into it. Now what I will do is I will either have a magic marker or put my thumb where that I'm going to end, flip the bar around, and start with the same amount of bending from the other side and come into the center. I think I'll be able to get one more that I'll feel comfortable with to be able to bend this. Let's see if I can get a little bit more out of it. Okay, now I will rotate the piece, start from where my thumb is so that I'll be able to watch my material from where that I just stopped from the other side, bringing the piece out progressively. You can see on how easy that I'm not really putting a whole lot of force into this. Even though that I am 240 pounds, that does help sometimes, but it doesn't really get you in the right category as far as being lean and mean. So Now I have a bent piece of aluminum that I will go to my template to see on how close that I am for having what I have pre-bent to the piece that I've made the template off of. Now that you can see where that we have pre-bent the piece on the bending table, what I call this here as far as being lucky, or by watching a material and knowing the control that you have off of your body to be able to bend your material. From here to the end of the material, as you can see, we need to go back up to the bending table and to be able to take some on out. So what I would normally do is put a mark of a magic marker area where that I know that I'm centered in my template for the area that it's good, and I will not put any of that part, any sort of bending in that area, but from my finger out to the outer portion where it needs to be adjusted to sit in the center. Here what we're going to be demonstrating is by using a pyramid roll on how easy this is to be able to bend. Having to be able to purchase a pyramid roll that you have to think, well, will it ever be beneficial to me? This works in many different applications, through doing curves on top of gates to being able to do staircases. Now, in adjusting this piece, when I was talking about 1 turn, 1.5 turns, or 2 turns, is what I'm reflecting upon the rotation of this top bar here. As you see that I'm screwing the piece up, brings the top roll, which creates pressure to be able to do the curvature on your flat bar. So how that I'm going to go ahead and put my flat bar into my pyramid roll, screw the piece down to where that it just hits the top of it, which is not bending the flat bar, but I know that my top roll is touching the top of the flat bar. Now what I will be doing is I will know where, which I have one end of this marked with tape, so I do not get confused between a positive and negative end here, that I will go completely over 180 degrees, extract my piece, then put this back exactly where the pyramid roll top roller will be touching the top of my flat bar if I were to put it back in there again. Now that you saw on my pre-bent pieces, by putting it on top of the template, that I was just a little bit more bend than 1 complete turn. So what I'm going to do is I'm going to rotate this 360 degrees. So that means that when I feed my flat bar into the roller, it's going to come out perfect or very close to the curvature that I need for the staircase. Now something else that, by just rolling your flat bar through your pyramid roll, these rollers on the side will put pressure to be able to make sure that your flat bar will come out flat instead of being curved. Now you can use this as far as turning it into a helix. I choose not to, which I use the bending forks that I'm able to do, and I have much more control instead of having something that doesn't work properly for me. But if you know your pyramid roll a little bit more, I'm sure that these side rollers would be able to benefit you not only through curving your piece, but yet to be able to turn it into a helix that will sit flat on top of your stringer also. So what I'm going to do is that I need to be able to roll this piece out a little bit further so that it does touch my material. Now I have adjusted the roller, so now that I do have pressure from this roller to be able to have it so that the flat bar will hopefully stay straight when I run this pass at this particular time. Never take your eyes off of what you're rolling here. If you ever see the cartoon with somebody that's gone through the washer wringer, that I would hate for your fingers to be in reality of that poor soul that got flattened in the cartoon. Tools are nothing to be toyed with. Now, from my piece that I have curved, one advantage with a pyramid roll that you have a uniform piece of material that is curved for the radius if it is uniform. Something about aluminum also, which if you were to have aluminum that has been sitting out in the sun for any period of time, or even just within a week, it will lose some of its softness. It will become more tempered. So that means that when you do your rolling, especially if you have the 4 bars, in this case in this design, that you will want to make sure that you have fresh material. This way that it will bend uniform instead of running it through the same setting, and you will have different curvatures throughout the same stock and the same setting. So make sure you do have fresh material when you're doing this. Now that we have bent this from the pyramid roll, I will put this on my template. One thing that you will see here is that we do not have much of a, here is a flat spot, which we have the last 6 inches, but yet the rest of the curvature is very, very close. Now you see the rocking and rolling of this right here? That means that that other roller, the back portion of it, did not have enough pressure to be able to push this flat so that it will lie flat on your material. With this particular area right here toward the end, I will put a magic mark right here, and to be able to tune this up better, I will go to the table and put a little bit of bend in this area here. Now I'm going to mark this piece with my magic marker. Another referral is to be able to mark on either side with a little arrow so that you will come back to the exact same spot, which you know that from here on out, at this particular direction, that you are fine on your curvature. But you can see not only that by having this piece wobble that I have to bend it flat, also that I have to be able to curve the piece in a little bit more by going to my pyramid roll, or to the table over here to tune the piece up. Now with having your pyramid roll, by not having it adjusted properly, this is what you will need to do by bumping it throughout a piece of flat bar, sighting it down. You want to be careful about putting too much into it here because you can develop flat spots and kinks. So now by having it on your table, see what I've done now, the thing does not rock. It's perfectly flat. So now I'm able to put it into my table for bending the piece so that it'll fit in the template perfectly here. What I am doing right now is to be able to have from my magic marker, from this side on over is good on the curvature. What I'm doing is I'm pulling just a very little bit to be able to bring this back into a little bit of a tighter radius, that I did not have my pyramid roll all the way perfect as far as having the top roller down, screwed down far enough. So instead of running your material through the pyramid roll for a second time, I would go ahead and adjust this piece. Then the next piece that I would put in there, I would make my compensation by screwing the top down a little bit more, another 1/8 of a turn or 1/4 of a turn. Now that I have adjusted my piece, I'm going back to the template to be able to see on how that the piece will fit. Using my marks, where that on the magic marker I know that I haven't flipped the piece, as you can see that I'm very, very close to where that I am as far as being in the center of the stringer. So what I'm going to do, just so that I can see this a little bit better, I'm going to go ahead and mark on either side, and then take my piece of material off and see how I am in the center of my material, of the template here that I've done off of the stringer. Now I'm doing a blue line here. Doesn't matter, it can be black. You know that the thickness of your stringer is 3 inches of what we have here. Now once you have the piece bent to the template, now the degree comes into place. I will be getting my smart level, and I will be placing my piece of flat bar in the vise at the very center of my bend, putting it to the degree, and then taking my 2 bending forks and twisting it by turning it into a helix. In your pre-measuring at the job site, by having a smart level that is a digital degree finder, is extremely important to be able to make sure that you can fine-tune everything perfectly. By having a protractor that is a adjustable degree finder, can be used, but it is not nearly as accurate as far as being able to use this particular tool to get your degree within 1/10 of a degree. What I will be doing now is putting my flat bar in the vise in the very center. Now this piece of flat bar can be on up to 14 feet. The longer, sometimes the better, but yet providing that when you do put the flat bar, you would like to be able to have this somewhere in the middle of your curvature. So I'm going to adjust the vise to be able to clamp it, to hold it in place. I'm going to take my smart level here. Now I would like to be able to have, it says on the template, 24.5 degrees. So I'm going to be adjusting my piece to 24.5 degrees. Now this is perfect. I have 24.5 degrees, and this area right here will actually throughout the whole piece. I'm going to lock this on in. Now it's always good, as you can see, that the vise did move on me a little bit. It's always best to be able to have a vise that will not move on you. It's very secure so that your degree doesn't change. Now what I will be doing is getting my 2 bending forks, and I will be holding on to one area and twisting the material. Now you can do this on the job site, but yet to be able to pre-do this in the shop will help you save some of the time of having a piece of flat bar, especially when you are getting into a 44 or 46 degree pitch, that you have one end that is sticking way up high and the other end is sticking down low. So by doing this particular pre-bending in your shop before you go to doing the piece on site will help you save time also. Now what we're going to be doing after we've set our degree in the vise with our smart level, I will be using these 2 bending forks to be able to turn the piece of flat bar into a helix. By starting from the very middle, again, that by using special parts of your body, your lats, and to be able to not to want to twist with both arms. You want to stabilize with the portion that's closest to the vise and only use the arm that is going to want to put the twist in your piece of flat bar. So I go ahead sometimes to be able to either have my arm locked where that I do not want to twist with both arms, but only with my bottom arm. Having your bending forks approximately about 1 foot to about 14 inches apart will keep you from wanting to kink your material. Now this is very important to make sure that you are not bending up or down, that you are keeping your flat bar and your bending forks approximately the same distance apart as you work down your material. As you can see, that little bit of twisting turned that portion into the helix. Now I'm going to go up to the other side here. I'm going to be able to hold on to this area and to this arm, and I want to bend from the vise on up. So keeping my hand up high enough gives me more mechanical advantage to be able to twist the piece. Now, the biggest mistake that when I first started doing this, I thought it took a whole lot of brute strength to be able to turn these pieces of flat bar to be able to sit on the curvature of your stair. You'd be surprised on the little amount that you twist will give you exactly what you want. Now what we have is putting it on the floor or on the table. You see that little bit of twisting that I've done has turned it into a helix. Another thing that you need to do is to be able to turn it up on edge and sight it down to be able to see if you have any wiggles that you have twisted too much in the wrong place where that you would have a hump. This is where that you will tune this on your stringer at the job site to make sure that your flat bar sits perfectly flat on your stringer. Now we are taking the piece that we have bent at the shop and also have twisted the piece into a preliminary helix and putting it on top of the stringer to see how it fits without it being bent up or down, and so it sits completely flat. One important thing is to always, when you have multiple different pieces from inside radius to the outside radius, you identify the piece with the degree when you are pre-bending it at the shop. Again, by having bottom and top marked at the shop so that you know that by taking it off of your template is perfect. One other thing is you need to make sure of is that when you are marking your template, you are actually having to make sure that when you twist your material that you are not doing it the wrong way, because you are marking this template upside down. Keep that in mind, that when you are twisting your piece of flat bar into a helix, that you are doing it the correct way because you have marked your template from the bottom side on the stringer. Now I'm about ready to go ahead and get rid of the crown or the belly, one or the other, with the bending forks to be able to make my flat bar sit completely flat on the stringer. It does not take very much at all to be able to make that work. Just from that little bit of bending from one point, which I held up here, to having my bending forks here, now the piece is completely flat, which down here at this particular end, it's sticking up a little bit, but I will be cutting my flat bar right here, so that doesn't make any difference at all. The usable area that I'll be using works perfectly on up to where that I am right here now. Now what I'll need to do is the same thing. I'm up off the stringer right here, so I will take my bending fork and bend from here down so that my flat bar will be hitting the stringer and lying completely flat on it without any pressure whatsoever. The reason for that is that the bottom, you could get away, but it's not advisable to not have this sit completely relaxed on the stringer. Where that it does really make the difference is the other bars that are running parallel to the staircase here, to make sure they are not up and down wiggling like a snake, because this will affect not only if you're putting a bronze cap rail on top of it, but yet also that the line is not fluid. So I'm about ready to take my flat bar and my bending bar. I'm going to put it right to where that from here down is all nice and flat on the stringer, and I'm going to put just a little pressure on this top portion to be able to bend it so that it will sit on top of the stringer. Okay, you keep getting a little bit further on up. What I need to show here also is that I'm going to put my bending bar here, and I need to be able to twist the piece because one side is down lower than the other side of the flat bar, so I need to correct my helix. So by having your flat bar, sometimes with having another person hold this, always seems to work better. Between your bending bars, again, that you want to have somewhat of a little bit of distance between the two. Now, it's not as if you're taking the two bending bars here and bending and using them both at the same time. You have to stabilize the one that you do not want to change any and only move the one that is on the upper portion to be able to change the helix. What I have done now with the change and getting my helix on either side of my flat bar is exactly the same, but I still am elevated up just a little bit off of the stringer. So I go back with my fingers on either side of the flat bar, feeling where that I start to leave my stringer from the flat bar. This is where that I put my bending bar, in that particular area right there, stabilize it, push down just a little bit, because it will bend, to be able to get the piece up further. So now I'm completely flat. Again, up here on the very top portion of this, I do have a straight section that will be cut off. So by running my fingers, I am good up to here. Up on the very top, I'm probably around about a 1/16 or so off of the stringer. It's extremely important to make sure that you are sitting completely flat without any sort of wobbling in the rail at all. Because again, this does affect all of the other bars that you will put on top of this here as parallel between either the circle design, the scroll design, or whatever that you will have on the very top. This is a tool that I prefer other than the Strataflex. This enables me to be right on the stairs, to be able to hold on to this hydraulic ram that does everything right in place without having to go up and down the steps, or to be able to find a flat spot to be able to use the Strataflex. This is a hydraulic ram. By pumping the piece, continues the ram down to be able to put more pressure on the flat bar. So all it is just a hydraulic tool that works very efficiently. We've returned to the house here, and what we are doing is to be able to create the framework for the staircase so that we're able to take it away from the house, go back to the shop, and do the rest of our infill. As you can see, with carrying on up to the top of the steps, that we have not only the landing, but the stairs that meet the landing. Now that we have completed with bending our flat bars, down here at the very bottom, we screw this down to the stringer so that it is stable. The next process is to be able to take a vertical bar, place this strategically over the top of each one of the screws that you have screwed the bottom stringer in. The reason for that is when you weld at the very bottom on the outside of your piece of 3/4 inch bar right here that's vertical, that by having a level on either side to make sure that it is perfectly plumb in both directions. Now we all know that when a weld is done that it wants to pull. So while the weld is still hot after the welder has just got done welding your piece, what you need to do is to pull it so that it is tuned with the level right on it so that it is perfectly level in both directions. After that you've welded the vertical bars to the very bottom piece of flat bar that's screwed to the stringer, now you're able to put the rest of your flat bar by welding it to the vertical picket that you have just got done welding. Depending on whatever sort of space that you desire between the two, that's where that needs to be welded. Now, providing that you cannot exceed any more than 38 inches for the top rail to the bottom or to the nose of the first nosing of your tread, cannot exceed any more than 38 inches. So now this determines where you place your top bar. So what I have done is that we have gone ahead and put our flat bar at the very bottom because we have 4-inch circles at the bottom. Next, I put my flat bar at the very top, which determines the total height of what I need to have. Then I bring my bottom bar on up to the flat bar by using a circle, or whatever that you choose to be able to use in between the two parallel bars as a spacer. So now you have 4 of your bars with what you have to work with for your design in the middle. The diagonal support bars that you see as far as an X, these areas here actually create a brace so that when you are transporting the material or the mocked up staircase, that the angles do not change. By doing them not only in large sections from bottom to top to keep the radius from changing, but also intermediate areas here also. The piece really turns into a great big wing. From this particular point at the top of the steps, we have the landing, the secondary set of steps, then up at the top, a very short landing. All of this is all one piece that will be taken back to the shop so that we're able to actually create our wave pattern design without having any sort of breaks in between. The example that we have on the upstairs landing here is a fine example as far as being able to fit all of your infill into a certain area. Again, that what I talked about earlier is that there will have to be certain compromises by taking that amount of space and condensing it into a small stair section, which will be the inside radius here that we have. So they will probably have to eliminate one of the bars that is 3/4 inch round that connects the casting to the other center of the wave design. Now we are at the point where we're ready to extract the pieces from being fabricated on the site back to the shop so that we're able to do all the infill. One thing that with these bars that are welded to the outside here will make the trip very safe without having any angle change or anything different other than what we have existing at the job site. We've arrived back at the shop now, and what we are about ready to do is to be able to show you how to be able to put your pattern off of your curved staircase to be able to create the pattern on a flat table. What we've done here is that we've incorporated the circles with the balls between the two parallel flat bars, top and bottom. What this does makes it so that we have a very rigid frame, and also that our inside dimension will not change anymore. We've created a gusset. As you can see also that we still have all of our cross members here that we will be working around. The vertical members here that we have that were leveled in both directions on site on the staircase, that we are going to use those as reference for the pitch of the stair. So what I'm about ready to do now is to be able to use a magic marker to be able to draw the limits of what my design is able to have. Also drawing straight down from the vertical or parallel or the bars that we have here to be able to identify the pitch that will be registering, as you'll see later on in the scroll work that we have before we go to the bending forks. I'll be marking down here at the very bottom. Again, it's important to make sure that your lines are very identified and very close to the exact framework that you have. Every vertical picket, I will be drawing a registration line. Again, this is what makes it possible for you to be able to mark your scroll work before you bend it in the bending jig. We have now taken our paper off of our existing framework. This enables us to work on a flat table to be able to draw our pattern out so that we are able to see where the code will fall for our 4-inch sphere. Also that we have our vertical measurements right here so that we are able to mark on our pieces that we are fabricating before we go into the bending jig. What we have done here, we have free-formed a design that we think that's going to work with the measurements. But as you can see from the consistency of not only with the rail that we have for the balcony, but yet by having this bar right here really has condensed the space inside the scroll. So the compromise that needs to be done so that our space between this bar is similar on how that the balcony rails are, we're going to eliminate this bar altogether. From making this compromise of eliminating this bar that's in the center here, now we are looking closer to what the landing sections will be. As you can see that we have had to rearrange the bar. Instead of having 2 run through this area right here, we'll only have 1, but it still is able to meet building code. Now, one of the nice little tools is for you doing aluminum that it comes in little spools, and you're able to use this as a test item for the code of 4-inch rule. This measures out at 3 7/8. So that means that you can use this piece to be able to check all the areas in your design to make sure that it will pass code. Again, the compromise of eliminating this particular bar, which is in the stair section, to this stair section here also, the compromise is this bar that would run into this area here and continue on up where we would have 2 bars in the landing, where that by having only 1 bar with the limited amount of space that we have is the compromise for this design. We have now made our very first scroll, even though that you see multiples on the table here, but we make 1 first. This enables us to lay the pieces on up the length of rail that we need to have to make sure that we're able to end without having a half of a design before we commit to making not only the jigs, but yet for the multiple pieces, we have to make sure that our first piece is going to work on our last space also. After making sure that all of our patterns will work at the very end of our design, this enables us to make the jigs because we're assured that by doing multiple operations will be the most efficient way as far as making a pattern. So what we have done here is that we have hammered the material, then we have heated the pieces up to be able to form around our jigs, which achieves 2 operations at the same time, not only by forming it, but by annealing the aluminum to make it softer after the hammering process. I have a piece of 3/4 inch round aluminum in my hand, 6063. If you are not able to get that, 6061 will work just fine. I'm going to run this through the power hammer to distress it, to put hammer marks, so then after that I'm able to anneal the piece. I've just taken my stock out of the furnace. I'm running my paint stick over the top. As you can see that it's smoking, and the black registration on the aluminum shows me how hot that it is. When I get up to an area where that it's cooler, it stops making a black mark, and I know that that is much less of a temperature. It will still bend, but yet I have relaxed all of the molecules throughout the whole piece here. The ideal situation is to be able to have the whole temperature all the way through so you do not have any hard and soft spots. I have now taken my piece of aluminum out of the furnace and I'm about ready to bend it around the form that is preset for the scrolls that we're going to have in the railing. By pulling and wrapping it around the piece, you can see how easy this is to be able to do. One thing that you must do is you must stop where it will not bend anymore. The reason is if you were to continue to bend, this part that is hot will leave the aluminum or the jig itself and you will have a bad spot. So now I will have to continue heating the rest of this either through the furnace or by using the rosebud tip. I'm about ready to go ahead and continue the rest of the heat, even though that I could use the furnace again to be able to continue the rest of the heat. But what I'm going to do is I'm going to use a rosebud tip. This one here is a rather large one. It has approximately 12 different tips at the very end. This is what you want to have be able to have enough of your heat going into a big area. What you see now is the same registration as far as using the paint stick to be able to see where your hottest temperatures are and where that they stop. I am past the bend that I've done before. I'm into the straight, which I will be able to continue throughout the rest of the jig. Now that the piece is hot, I'm pulling it around the corner all the way to the very end. Now if you are just about at the very end and you start to see it's starting to pull away from the backside of your jig, by putting a pair of bending forks on the area that's soft, then you're able to continue the rest of it without it pulling away from the jig. We are now ready to be able to locate our angle to be able to transport the lines to marking on our scrolls that we have created. Having a very large angle finder here helps tremendously because you're able to get the full distance. I have this right over the top of the paper, and the piece that I have marked, which is the vertical 3/4 inch square bar that's on the railing, I'm using that as my vertical measurement along with my parallel bottom bar. I will take this piece, I will go on over to the scroll that I need to be able to be marking, line up my bottom piece, my angle finder with the bottom flat bar. Now I will take my magic marker and do lines that will be in the same pitch, that will actually be a level mark, that I will be able to take this as registration marks to my pipe bender to be able to start the curvature of the piece of material. Now, one thing that happens is that the castings here over this distance and a very sharp radius is going to be very difficult to be able to bend. In some cases, you have to be able to find areas that you might have to cut and re-weld again. Sometimes that you can go ahead and heat them on up under very small amount of pressure by pushing it very easily around a formed piece that has the same curve. There's two different ways of trying it. One is cutting it, and the other is heating it up and see if it will bend if it is a very small amount of bend. But you do need to be able to do this because these here are cast straight. Now, if you have multiple rails that in an operation, I would suggest having the foundry or the pattern maker do a curved piece, so then you aren't have to do each one, especially if you have many different types of patterns that you have to curve. What you're going to see right now are the markings from the magic marker that we have placed on here with the angle finder and the pitch of the stair that we need to have. As you can see that they are off on an angle. If you were to bend this at this particular pitch, it will not fit inside of your curved stair. So by rotating this down, this here, as you can see, that the casting is getting close to the pitch that it needs to be, and these vertical lines right here is where that I will be putting this into the bending forks. So this means that a piece of pipe that you have here works excellent, because now these marks that we have here that I will see to make sure that it is parallel to the pipe. There are two different ways as far as bending this. One is with a bending fork. Sometimes that it's on a little bit of a rough angle where that you aren't able to actually bend it correctly. So this is where that you would use a dead blow hammer. This has shot in the middle of it. You want to be able to get the biggest one that you can, which will give you the most amount of force without damaging a material. A rubber hammer can work, but yet a hammer that has shot, little balls inside here, gives you a terrific amount more of momentum. In some cases, when I start to do this here, that you will probably maybe break a casting. Sometimes that happens, sometimes it doesn't. Another thing is that the reason that I have selected aluminum more so than steel is because you'll see on how easy this will move. Because the massive amount of material, especially at 3/4 inch round, if this was steel, you would not be able to hit it and to be able to make it move at all. In this case here with aluminum, I'm putting pressure with my hand down in this area. I'm making sure that I am parallel with my marks where that I need to be. That little bit just right there what I'm hitting. What is happening is I'm only bending from here down. Over here it has not bent yet, so I might have to take the piece, turn it around the other way, support it where that I'm able to have this pipe bar up here in this area over the top of the casting and hit this down just a little bit. I'm also going to push on this here a little bit. I will gradually bring the piece through. See, what's happening is I'm bending it really from here on down. I still have to turn it around for the other direction. Just that little bit of hitting, you can see I'm starting to curve the piece. I take my piece, turn it around in the other direction, still using this, my parallel lines, supporting this end up underneath the pipe. Sometimes you might have to have pipes that are a little closer together for tighter radiuses. So I'm not sure if you can see this here, but the curvature, just within a small amount of blows, you would not to be able to achieve this with steel at all. Now you've seen what the bending forks and the parallel lines are able to do and how easy it is to be able to move aluminum, especially after it's been annealed. So now what we're going to do is we're going to take our scrolled bent piece and insert it into the rail, see how it fits. In order to make sure that your pieces are not projecting out any further, is to be able to take another straight bar and having it parallel to these bars right here to make sure that all of your pieces are not that are all over the center of your flat bar. As you can see, that with that little amount of hammering, it's gone very easy to be able to move this piece. No heat at all done cold. The other piece that will be, to be able to fill up this area right here, will be a small piece where that we had two before in the landing area, but the compromise again is right through here, and the space that you're seeing through these areas here are very similar to the landing instead of being quite so congested. What we have done here is that now we have taken our bent piece, we have inserted it into the rail. As you can see that we've already have one that's already in the rail itself. Now it's always a good idea to only just tack your pieces in place so that you aren't committing to something in case there's a mistake somewhere along the line. Also, as far as being consistent in the layout that you've done prior to actually making all of these scrolls, that you're pretty certain everything is going to fit perfectly. You've just seen all the different processes in order to how to complete a curved staircase. To be able to review what we have just completed here, I'd like to be able to go over this for a second. As far as when the client placed the order, he had a design concept. Next, we were able to see what sort of materials were to be able to be used. One, aluminum was selected in this particular material because of the easeability, which was shown in the other portions of this video. Next is to be able to find the templates of pattern making so that we're able to find not only the degree but the contour of the curved stair using 1/8 inch Lewin. Next, we were able to pre-bend our material at the shop, which I call this a kit, prior to going to the job site. After doing our kit, we're able to travel to the job site to be able to fine-tune the flat bar, also to be able to create the curved portions elevated into a rail that will be used as a final product, not as a throwaway, by using support members and other pieces. Next, we brought the pieces back to the shop. We were able to show as far as how that you're able to transpose the pattern from paper with the curvature of the stair onto a flat table, making scrolls, jigs, and other pieces so that we're able to start our rail continuation. Next, we were able to go ahead and show the process of pre-bending, not only using tools and other pieces, that we would be able to make this job much easier, which was shown that by annealing your aluminum made the whole project that much easier to be able to do the contour of the pieces that went inside the contoured curved staircase. Next, we were able to show as far as with the process of installing these pieces into the rail. Finally, the finish as far as on the rail is where it's a matter of selection on personal preference. In this case, we chose to be able to powder coat the process of not only using electrostatic paint, which wraps around uniformly, is baked on with approximately 300 to 400 degree temperature in an oven, means that one, that I don't have to do the painting myself, and two, I'm able to actually have quite a number of powder coaters in the vicinity that I live in. An alternative is that if you do not have a powder coater that is very close to you, as far as preparing the aluminum and blending all of your welds together by sandblasting it lightly with a 3065 grit sand, then using a heavy mill epoxy primer. In this case I use a Kolar, which is a DuPont product. Then next I use an automotive paint over the top of that. Then, in case that I wish to be able to faux finish it with latex washes or other applications, you're able to do this with this much easier because the paint isn't quite so tight as it is in powder coating. The final installation process is extremely fast. All it takes is to be able to bring it into the house, bolt it down. If you have any sort of welds between the two, that's all it takes, and you have a finished product. This concludes our educational video on curved staircase. Thank you very much.